Hi everyone, my name is Leonardo Sanchez and welcome to my Capstone project presentation for the Google GenAI course. In this case I want to present YODA, which is the prototype I have been working on. YODA is an acronym for YouTube Opportunities Discovery AI. So basically YODA analyzes popular YouTube content, focusing in this specific case of this demo on the Brazilian market. It's applicable to any other market, obviously. And we are looking to uncover why popular videos succeed beyond their standard metrics. So to give a glimpse of the use case, so creators need deeper insights than just view counts into why their videos are succeeding. So YODA provides this through a multi-step pipeline. So we fetch video metadata, we pre-process it, we download these video files, we analyze the video content using multimodal GenAI capabilities, we fetch and analyze the comments made on YouTube, we extract and analyze keyframes, and we generate a per video summary using all of these inputs. And as a final step, as a final output, we use the same GenAI to generate overall insights, comprising all the per video summaries that we have gathered so far. So crucially, to ensure ethical AI development and respect copyright, this demo and in this prototype focuses specifically on videos licensed under Creative Commons. So starting with the code implementation itself, I have worked here to make sure that we have the proper libraries functioning and set here. I have defined a few constants and configuration in the very beginning, such as working with Brazil, working with 20 videos, 15 minutes as the maximum duration in minutes for a given video, obviously because of cost implication. And I want to talk briefly about the model that I've chosen for these. So I chose the Gemini 1.5 Pro because of its powerful multimodal processing, strong reasoning, large context window capabilities, and all of these make it ideal for these complex analysis that we have in this demo. I also made sure that we have standard safety settings here so we can make all the calls applied in compliance with responsible AI use. For the different configs of the different callings, I used a temperature of approximately 0.7 because it provides a good balance between analytical focus and insight generation for this prototype. This pipeline uses two different API clients. The first one being YouTube, the YouTube client. We are using the YouTube Data API version 3, mostly for gathering the videos, its metadata, its comments. And we are also using the Gemini API client for the Google the Gemini 1.5 Pro for all in this entire notebook. I also want to really quickly explain a few of the functions. In the next session here I have some helper functions. They handle tasks in different parts of the pipeline, such as fetching data from the YouTube API, downloading videos, processing video content, interacting with the Gemini API, And so we have different functions here. The first one is the fetch popular videos. Parsing the and passing the different settings for these demos, such as Brazil, 20 videos, maximum duration 900 seconds, and so on. And as you can see, we pass it here alongside with Creative Commons, which is an important aspect of this demo. And in the end, we are getting different details such as the video ID, which is key for this demo, the title, the description, the channel title, the channel ID, when it was published, the view count, the like counts, the comment counts, and so on. And well, this function basically it returns the videos sorted by their popularity, by their view count and their like count. Then later we have another set of functions such as clean, preprocess, so we can transform this into a data frame. We have the fetch comments, but I want to jump into this is a long part of the Jupyter Notebook, but I want to talk about the multimodal analysis, which I feel is this is the analyze comments with Gemini. And let me jump into it's a lot of so this is the one, analyze video multimodal. So we provide a video path and the model instance, and basically what it does is it uploads a video file. We use the video path here in the Kaggle environment. So we get that video when we upload into the Gemini API, and we request a comprehensive analysis, including the video and the speech to text transcription, and to help us to determine the popularity factors. And then later we clean up the API file, we delete the video that was uploaded. But what I want to show here is that, well, we basically get we upload the file here, and later we provide a prompt where we ask for, this is structure, right? And we provide a long description of what we want. So in this case, we want a comprehensive analysis of high performance YouTube video in Brazil. We are given clear instructions for the AI to analyze the provided video. We are saying, well, this content is in Portuguese, but we want the output to be in English. I want to use the exact headers below. And we are analyzing for things such as central theme and key message. What is the core topic? Key visual elements, key audio elements, characters and entities present, inferred target audience. So we are doing a long analysis here. Also requesting a full speech transcription in Portuguese and a speech analysis for popularity over that context, over that Portuguese context, asking for what can be clues for its popularity. So we are also asking for some visual factors that can explain the high performance, and executive summary, providing a concise, summary of the video content purpose and key success factors, both visual and in this case verbal. So basically we use that prompt and the object in the Gemini API that we uploaded using the video file to get that. And well, this is what I wanted to show. I'm going to quickly show you the main logic, because so step one, we fetch the video metadata, with that first function, 20 videos in this case. We pre-process and we transform that into a data frame, which will be the data frame through the entire Kaggle Notebook, in this case the f_videos. And we will use the video ID column to to manage this. You can see here it's how it looks like, the view count. You can see pretty popular videos in here, the like count, the comment count, the duration, seconds. You can see that all of them are Creative Commons and from Brazil in Portuguese. We made sure that. And here we download using a common popular framework library, and we download those videos. Then later I applied here the multimodal analysis using the function I just explained. And we put this into the same DF underlined videos as Gemini analysis. Then we do the comments analysis. So we fetch the comments using the YouTube client, and we apply the Gemini function to analyze those comments, and we store in the F videos comments. Later we extract and also analyze keyframes using the same Gemini model. We'll be storing this into frames analysis, and as the 7th step here, we'll be generating a final popularity summary, in this case per video. So I want the Gemini model to analyze all of these outputs, such as video and audio, but also comments and frames and its metadata, so it can tell me, why do you believe this video was popular? And well, we stored that into a Gemini summary column, and basically in the end what we have is something like this, where we have the video ID, the title, the different analysis, and the Gemini summary explaining the popularity, where it comes from. We save this into a CSV file, and we apply the Gemini model one last time to provide us the overall actionable insights from a content creator or producer perspective. And we analyze all of the Gemini analysis, and we give this long context for it to provide us the actionable insights. So in this case, the GenAI is telling, well, there's a lot of humor, fast-paced editing, there are many relatable themes that people resonate with them, like heartbreaking, relationship challenges. This is pretty interesting, Brazilian pop culture references, which the GenAI model was able to capture. And it provides some key engagement drivers. And in the end, this is the juicy part, it provides the general strategic recommendations for Brazilian creators. So what is actionable, what they should be doing for the content to succeed in general. So this is it. In the end, well, we delete the file, with the downloaded videos, and here's to provide some video attribution on the Creative Commons videos used, to give them credit, because their video was what made this demo possible. So this is it. So just to finish this, I want to say that YODA showcases how multimodal GenAI can provide deep content-aware insights beyond the standard analytics. Future work could involve scaling and refinement of this prototype. And that's it. I would like to thank you all. This course was amazing. I want to thank so much everyone in Google, in Kaggle, and in DeepMind for this amazing opportunity. I'm so excited about applying this in my future work, in my life. So I want to thank you all very much for it.